Chapter 9, Section 6, Part 2, Solving Rational Equations. So here it says, solve the following equations. You must check for extraneous solutions. Which means you need to know what the restrictions are. All right, so same deal. Get the LCD. I'm going to write the LCD over 1. My LCD is quantity 2x plus 7 times quantity x minus 1. I'm going to write the equation inside. X over 2x plus 7. Remember, these are quantities. Equals quantity x minus 5 over quantity x minus 1. Distribute. We only have two fractions this time. The first fraction on the outside multiplied with the first fraction on the inside. The 2x plus 7s are going to divide out, right? Leaving me with x times x minus 1. Equals. This time the x minus 1s will divide out, leaving me with quantity 2x plus 7 times quantity x minus 5. Distribute. X squared, subtract x. FOIL, 2x squared. This is going to give me negative 10x plus 7x. Well, negative 10x plus 7x is negative 3x. 7 times 5 is 35. It's negative. Okay, so I did a little FOIL and combined like terms right away. I'm expecting that by now you should be able to do that as well and not have to write everything out. It takes you longer to write stuff out. Now notice the equation is quadratic because even when I subtract this x squared over here with this 2x squared, it's going to remain quadratic. So I have to move everything to one side. Subtract x squared, add x. Subtract x squared, add x, right? See, I'm lining it up. So the left side is 0. 2x squared subtract x squared is 1x squared. Negative 3x plus x is negative 2x minus 35. It's quadratic. You have to factor. 0 equals, a is 1, that's nice. Multiplies 35, subtracts to 2, that would be 5 and 7. So x, 5, x, 7. Signs are different. Larger product is negative. 7x is bigger than 5x, so that gets negative. This gets positive. ZPP says x is negative 5 and x is 7. What can't x be? X cannot equal negative 7 over 2, right? If I set this equal to 0 or not equal to 0, subtract the 7, divide by 2, negative 7 halves, and x can't be 1. Those are my restrictions. My solutions are not the restrictions. So there's my solution. All right, let's take a look at the next example on the page. Now, I know you're going to be tempted to want to keep this as 2x plus 8, but you should not do that. You need to factor this. All right, this is GCF. Two terms is always either GCF, dots, or cubes. Well, it's not dots and it's not cubes, so it's GCF. 2 times quantity x plus 4. And you see what happens here is this x plus 4 is that x plus 4. So it makes us to be able to get that actual least common denominator. All right, so my common denominator is I need the x plus 4 and I need the 2 because that x plus 4 is already in there. So it's 2 times the quantity x plus 4 over 1. I put a bracket and copy my equation. 2x plus 14 is a quantity. Yeah, I understand there's a GCF in there, but I'm going to leave it like that for now because it doesn't pay me to factor it. Right? Because if I take a 2 out, it's not going to be an x plus 4 anyway. All right, subtract 2. I'm going to rewrite the 2 as 2 over 1, just so that they all look like fractions. And here I've got a 2x plus 20. And again, I'm not factoring it because I'm presuming that I am going to have to FOIL and combine like terms. So factoring doesn't make sense for this. And I'm writing this in factored form. Remember, I factored the 2x plus 8 into 2 times quantity x plus 4. All right, now I'm ready to distribute the outside fraction to the first, second, and third inside fractions. All right, and when I multiply these two fractions, the x plus 4's divide out, leaving me with 2 times the quantity, 2x plus 14. Subtract, right? Positive times negative is negative. These are both 1s. So here I've got a 2 times x plus 4 times 2. You can multiply the 2's right away and get a 4, but I'm going to show it as 2 times, and then here's my LCD, 2 times x plus 4. Equals, notice when you multiply the outside fraction with the third fraction, the LCD is going to kick out the whole denominator, so you're left with 2x plus 20. All right, let's start removing grouping symbols. This is 4x plus 28. Subtract, 2 times 2 is 4 times the quantity x plus 4. You can't multiply this 2 in there and this 2 in there. Okay, it would be too much. So 2 times 2 is 4, and then here's my quantity x plus 4 equals 2x plus 20. 4x plus 28, subtract 4x, subtract 16 equals 2x plus 20. Combine like terms on the same side. 4x subtract 4x is no more x. 28 subtract 16 is 12 equals 2x plus 20. I'm going to switch sides. 2x plus 20 equals 12. I'm going to take the 20 over to the other side. 2x equals negative 8. Divide, x is negative 4. All right, now I have to look for my restrictions on what x can't be. Well, a 1 is not going to be a restriction. A negative 4 is a restriction. This gives me no restrictions. A 2 is not a restriction. A negative 4. So x can't be negative 4. But we're saying x is negative 4. So what we have here is no solution. Or you could write it as the empty set. If you have any questions, please don't hesitate to ask so I can help you. All right, we've got one more problem to do. All right, here's my equation. Same thing, get the LCD. What is the LCD? Well, the LCD is just x minus 2 over 1, put a bracket, negative 6 over quantity x minus 2 equals 3 over 1, subtract 3x over quantity x minus 2. Okay, so set up the visual. X minus 2's will divide out, right? I have to distribute this. All right, so what remains on the left side? Negative 6 equals, this 1 is not going to divide that out, so that's 3 times quantity x minus 2. These x minus 2's will divide out when I multiply this with that, leaving me with 3x. All right, distribute to remove grouping symbols. Combine like terms on the same side. Look what happens. My x goes away. That's 0. Negative 6 equals negative 6. That's a true statement. When that happens, when your variable goes away and you get a true statement, then my solution is all real numbers except the restriction. X can't equal what? 2. This tells me all real numbers, or negative to positive infinity. This says not 2. So when I bring these together, I can write my solution set as negative infinity to 2, parenthesis, because it can't be 2, in union with 2 to infinity. So that's my solution set. All right, we write it in interval notation, kind of like the domain, because X can be anything. Okay, it's not just limited to 1 or 2 values. All right, so again, when this is true, then it's all real numbers, which is negative to positive infinity. But you have to consider your restriction. Now, folks, if that was false, then there would be no solution, okay? If the variable goes away and the statement is false. For example, 2 equals negative 2. Then there is no solution. Okay, so you would have empty set. So to reiterate one more time, we went through the solving process here, multiplying by the LCD, distributing to every term in the equation. We combined our like terms. Our variable went away, and we ended up with a true statement. I could take this a step further and add 6 to both sides and get 0 equals 0. It's still true. Because it's true, negative to positive infinity is what our solutions are, except the restriction. Okay? Now, if the statement is false, then there's no solution. And we don't even have to worry about the restrictions because there's no solution at all. All right, if you have questions, you know what to do. Don't hesitate to reach out. Have a great day.